So we move to the right, and now the method is about to return. This means we'll step out of the method and into the function that called it. We can ask the debugger to show us which method that will be. I can use the command where or W to print the call stack for the current program state. And we see that we're on line 63 of the step method, which was called by the run method in line 34, which in turn was called by run maze in the TK demo module on line 179. And that in turn was called by the TK inter framework in its main loop when I pressed the run maze button. So now that means that when I say next, the function will end and we will end up one level higher in the stack. So we will end up in the run method on line 34. Let's see if that actually happens. And yes, of course, we ended up in the run method and not on line 34, but one line lower on line 35, which is at the top of this file here. We just called step, and now we're going to yield the current location of the runner to our calling function. And we saw that that was the run maze method in tkdemo.py. So now if I say n for next, first PDB signals us that we're going to return from the current function. And then when I say next, I end up in the run maze method. Now again, of course, we can call L for list to look at the current code, or we can call W to look at the current stack trace. And of course, the current stack trace will be shorter because it won't contain the two methods that we just stepped out of. Now, a nice thing is that the self.update runner method will update our user interface. So now if I say N, we see a new breadcrumb appear here in the maze for our new position. So all of that is very nice, but actually I'm more interested in fixing my algorithm. I can press C for continue, and the debugger will let the program flow continue normally. Now I'd like to do that and start debugging again when execution enters the step function again. And to do that, first I will set a breakpoint to start a new interactive session as soon as we reach a specific line of code. You can set a breakpoint with the B command, and let's ask for help about the B command with H, which stands for help. And as you can see, we can set a breakpoint with a file name and a line number or a function name. And let's start by using a file name and a line number. I know that the step method is on line 58 of my program, so I can say, this will set a breakpoint on line 58 of my runner module. Very well. So now if I press C for continue, the program flow will continue without debugging until we hit this line of code. Very well. So now I'm in my step method again. Listing the code, we can see that a breakpoint is set in this line now because there's a B here. So let's go on and debug. There is a wall on our left hand. We're still facing east, so this will be false. And we will end up in the else statement. Let's check. I'm going to do N. Very well, so we're here now, while not self can go forward. And actually I'm facing a wall here, so I can't go forward. So I expect to enter the while loop here. And that's exactly what happens. So the call to self.rotateRight should rotate our direction 90 degrees to the right. And before calling it, let's see what the current state of our program is. Very well. Currently we're facing east. Now let's run the rotateRight method by saying next. And let's ask for our new state. And now actually we're facing west instead of south, which I expected. Because of course if you're facing east and you rotate for 90 degrees, you would face south after. But actually we're facing west here. So apparently the bug is in the rotate right direction, because it didn't rotate 90 degrees, but it rotated 180 degrees. So let's set another breakpoint in rotate right this time. This time, instead of using a line number, I'll use the method name. So the breakpoint is set, and now I can continue to see the runner walk until it has to turn right again. I'm going to say continue, and we end up in the next call to our step method. And actually now it faces left again, so first it will step back. Very well. And now you can see it moved down, moving down again, moving down again. It has to turn left here. Very well. And now we're facing a wall again, and we have to rotate right. So now if I say continue, we end up in our rotate right method. Now, of course, if we examine the stack trace, we see that we're in the rotate right method, which was called by step, which was called by run, etc., etc. Now, this is the actual line that contains our bug. It takes the current direction index and adds 2 before taking a modulo 4. Now, executing this and looking at the new state, we see again that it turns around 180 degrees. And actually, what I should do is increase the direction one more, and I can do that right now. Very well. And now actually we're facing south. So that's our bug. Instead of adding 2 here, I should add 3, and that will make us rotate right. So let me fix that here. Very well. And I'm going to quit the debugger here. And then of course, don't forget to remove our debugging lines here. And let's run the demo again. And now you see the maze runner runs and solves the maze.